This module covers the components that comprise the -8Q400 electrical system. The module discusses the controls for each system and what they accomplish, the various electrical indications and their presentation, the faults and failures that can occur, and the visual indications presented for each, and the few electrical limitations. The -8Q400 supplies all required electrical power for airplane and equipment operation through the Electrical Power Generation and Distribution System, called the EPGDS. The EPGDS provides the necessary components and controls to monitor the system, distribute the power, charge the batteries, protect for system abnormalities and faults, activate load shedding for energy conservation, and give indications of the system's status. The -8Q400 has two types of electrical generating systems. The main power source is the direct current or DC system. The DC system includes the battery system. The other system is the alternating current system or the AC system. The DC electrical system power is supplied by 3 nickel-cadmium or NiCad batteries, each rated at 24 volts DC, 2 engine-driven starter generators rated at 28 volts DC, 2 transformer rectifier units rated at 28 volts DC, 1 auxiliary power unit or APU engine-driven starter generator rated at 28 volts DC, and DC external power. The AC electrical system is supplied power by 2 engine-driven AC generators that are mounted on the propeller reduction gearbox. Each generator provides 115 volts, 3-phase variable frequency AC power. A 115 volts AC external power source is available to energize the aircraft AC system when the aircraft is on the ground. Power distribution for both systems, the DC and the AC, is accomplished through an electrical bus system. The electrical system has an electrical power control unit. The electrical power control unit reconfigures the system automatically should there be a power source failure or a bus fault. The aircraft's entire electrical system can be powered using only the AC generators, or when on the ground, AC external power. These sources are sufficient to power both the AC and DC systems. The DC electrical system receives power from 3 nickel-cadmium batteries. The main and auxiliary batteries have the same rating of 24 volts DC, 40 ampere hours, and are located in the aircraft nose compartment's lower left section. The main battery is in the forward position, and the auxiliary battery is in the aft position. The main and auxiliary batteries are used for engine starting. The standby battery is a 24 volt, 17 ampere hour battery located in the nose compartment since the aircraft is equipped with an APU. The batteries also assist during external power starting. The standby battery is located in the nose compartment's left side upper section. The standby battery is not used for engine starting and has a one-way power flow from the left DC main bus for charging only. In flight, the 3 batteries provide approximately 60 minutes of emergency backup electrical power to the left and right essential DC buses when necessary. The hot battery bus is powered from the standby battery. The bus provides the electrical power for the critical systems to operate during an emergency. Click on the battery bus to show the system power by the hot battery bus. The items and systems powered from the hot battery bus are clocks 1 and 2, the battery master switch, the battery power for refueling, the fire bottle's discharge squibs, the fuel and hydraulic shutoff valves, the cargo compartment's fire systems, the APU fire bottle squib for a manual discharge, the boarding and the flight deck dome lights, and emergency power for the passenger address system. The DC control panel is located at the top left side of the flight deck overhead panel. The control panel's upper row of switches is outlined in a yellow hatched rectangle. The 4 switches within the rectangle are the battery control switches. The battery master switch, at the upper right on the control panel, is a 2-position switch. It is lever locked at the off position. Selecting the switch to the battery master position simultaneously connects the 3 batteries to the essential buses. The main and standby batteries are connected to the right essential bus. The auxiliary battery is connected to the left essential bus. Click on the battery master switch to connect the batteries. The essential buses are now powered from the batteries. Before the main, auxiliary, and standby batteries can power all the related DC buses, the battery master switch has to be on. Essential bus power is required for the individual battery switches to operate relays. The relay connects the battery to its DC main bus. The connection of the batteries to the essential buses is independent of the electrical power control unit. The electrical power control unit receives its primary power from the standby battery. The connection is through a direct lead and indirectly from the essential buses. The three switches to the left of the battery master are the individual battery switches. Working from the left are the main battery, the auxiliary battery, and the standby battery switches. Selecting the main battery switch to the main battery position is the same as on. This action directly connects the main battery to the right main DC bus. The connection provides for a two-way electrical flow. The flow provides main battery charging from the DC bus or battery power flow to power the DC bus. The next battery switch selected to the auxiliary battery position, same as on, directly connects the auxiliary battery to the left main DC bus. It also has a two-way power flow. Selecting the last battery switch to the standby battery position, or on, connects the standby battery to the left main DC bus. The connection only allows a one-way power flow from the DC bus to the standby battery. This provides battery charging. The electrical power control unit logic inhibits the batteries from being connected to the main DC buses if there is a bus fault on the relative bus or during emergency electrical operations. A main, auxiliary, or standby battery caution light illuminates for the related battery if its switch is in the off position. The switch manually disconnects a battery from its associated main DC bus. The battery caution lights also illuminate if the battery automatically disconnects due to a fault. To monitor the battery loads and temperatures for proper limits, it is necessary to see an electrical systems display. To view the electrical systems page, you must bring it up on one of the two multifunction display units. This is accomplished using the Engine and System Integrated Display Control Panel. The panel is located in the center aft portion section of the flight deck center console. To display the electrical system page on either MFD1 or MFD2 requires rotating the applicable MFD1 or MFD2 revision selector to the system position. The electrical page is the default page. This means it is the first system page to be displayed when the revision selector is placed in the system position. Click on the MFD2 revision selector. This is the electrical system page. The push buttons between the revision selectors bring up the applicable system page on the multifunction display. If the revision selector is already in the system position and another system's page is displayed, pushing the electrical system push button displays the electrical page on the multifunction display. If both multifunction displays are off or are not set to the system position on the Engine and Systems Integrated Display Control Panel revision selector, pushing in on the electrical system push button displays the electrical page on the engine display. The engine display has to be on to view the display. The electrical page provides a complete overview of the airplane's electrical system. The page has advisories for external power connected for both DC and AC. It displays information for the batteries, the DC buses, the APU generator, the DC generators, the AC generators, and the transformer rectifier units, or TRUs. The battery display information in the upper left portion of the page shows the load and temperature of each battery. The display of load and temperature is in digital format. If battery overheat condition develops, the battery temperature monitoring activates. The activation causes the illumination of the associated battery warning light. There are 3 battery hot warning lights on the overhead annunciator warning light section right side. From inboard outward, the lights are standby battery hot, auxiliary battery hot, and main battery hot. The red warning light segment illuminates flashing, as does the master warning light. The master warning light illumination is accompanied by 3 audible chimes. The activation temperature to illuminate any of the 3 battery hot caution lights is the same. When the temperature of a battery is greater than 71 degrees Celsius, the warning light illuminates. When the battery temperature drops below 63 degrees Celsius, the warning lights extinguish. An overheated battery changes the digital temperature display on the electrical page. When the battery temperature is within the normal range, the digits are displayed in white. The battery load is displayed in white. When a battery's temperature increases to 50 degrees Celsius, the digital battery temperature display on the EIS changes to amber. When the battery's temperature increases to greater than 65 degrees Celsius, the temperature display changes to red. When a battery's temperature reaches 65 degrees Celsius or higher, the digital display changes to red. When the temperature of an overheated battery cools to 63 degrees Celsius or less, the applicable battery hot warning light extinguishes. Click on the battery to see the battery hot warning light extinguish. The DC control panel has a row of switches below the battery switches. The switch at the lower right position is the DC external power switch. When DC external power is connected and operating, it is sufficient to power the airplane's DC electrical system. To receive power, the switch is selected to external power, which is the on position. The receptacle for the DC external power is located on the left side of the airplane nose section. DC external power is connected directly to the left main DC bus. Automatic bus tie closure permits the DC external power source to power all 6 DC buses. The 6 buses are 2 essential buses, 2 main buses, and 2 secondary buses. When the DC external power is connected and selected on, the green DC external power on message illuminates at the upper left corner of the multifunction display electrical page. The electrical page is also referenced for verification that the ground power unit is providing adequate voltage to all 6 DC buses. The voltage on each bus is in white digital form. The electrical power control unit provides electrical system protection from external ground power malfunctions. The electrical power control unit automatically disconnects the external power source when it detects an overvoltage or undervoltage occurrence. The disconnection is activated if the external power voltage exceeds approximately 31 volts or decreases to below 22 volts. After the ground power malfunction is rectified, the DC external power switch requires cycling to the off position and back to the on position. The switch cycling resets the electrical power control unit protection logic. The 2 switches on the DC control panel left side lower row are the number 1 and number 2 generator switches. The switches control the engine-driven DC starter generators. The switches normally remain in the generator 1 or generator 2 or on position unless required to be selected off due to an abnormality. When DC external power is supplied to the aircraft, the engine-driven generator and the APU DC generator are inhibited from connecting to the main buses. When the DC external power switch is selected off, the engine-driven DC generators and the APU generator power the 6 buses, provided the generators are operating with switches selected on. With the engines operating, the generator switch is on, and the DC external power switch selected off, the main to secondary bus ties remain closed. The closed bus tie keeps the secondary buses powered until such time as the AC generators are online. The secondary buses are powered by AC generators through the TRUs. For the AC generators to operate and come online, the condition levers have to be at or advanced forward of the 850 RPM position. The DC starter generators are mounted on the right side of the engine's accessory gearbox. The generators are air-cooled by air that enters through a round opening on the right forward side of the nacelle. The air is ducted around the starter generator and vented overboard through a vertical rectangular opening on the aft portion of the nacelle engine access door. Monitoring and control of each starter generator is accomplished by its respective generator control unit or GCU. During engine start, when the high-pressure compressor reaches a speed of 50%, the GCU converts the starter generator from the starter mode to the generator mode. The high-pressure compressor speed is referred to as NH. The 2 GCUs are located in the flight deck behind and outboard of the first officer's seat. Each starter generator is rated at 28 volts DC with a maximum load of 400 amps. The GCU ensures the generator maintains the proper voltage supply to its associated main DC bus in response to the load demand. The DC generator loads are displayed on the electrical page and shown in white. 1.0 is an indication of 100% load on the generator. The voltage output is read as the main bus voltage. Remember, if external power is not on, and the DC generator switch is in the related generator 1 or 2 position at 50% NH, the generator begins to provide power to the main bus. The generator switches remain in the on position and are only selected off because of a starter generator malfunction. The starter generator is automatically removed from the system by the electrical power control unit for various electrical malfunctions. The electrical power control unit takes the starter generator offline when a fault occurs, overriding the selected generator switch position. Should an electrical power control unit take a generator offline, or the switch is manually selected off, the appropriate number 1 or number 2 DC generator caution light illuminates. Click on the generator 2 switch to see the next indication. A starter generator overheat condition results in the illumination of a number 1 or number 2 DC generator hot caution light. The electrical power control unit logic does not automatically remove the generator from the electrical system in this situation. The pilot is instructed by the abnormal procedure to manually select the generator switch off. Shutdown of the overheated starter generator allows it to cool. The affected generator hot caution light extinguishes once the generator has cooled. The APU is located in the aircraft tail cone and is used for ground operation only. The APU starter generator provides 28 volts DC and a maximum load output of 400 amps. The starter generator is rated the same as the engine-driven starter generators, but is not interchangeable. The controls for the APU DC starter generator are located on the APU control panel on the overhead panel. Generator selection is accomplished with the dual segment push button labeled Generator. When selected on, the APU generator control unit closes a relay to connect the starter generator to the right main bus. The electrical power control unit logic closes bus ties for the APU starter generator to provide 28 volt DC power to all 6 DC buses. The APU generator supplies power to the right main bus in parallel with the engine-driven starter generators and the main and auxiliary batteries. Transformer rectifier units, referred to as TRUs, change 3-phase 115 volts variable frequency AC input power to 28 volt DC 300 amp maximum load nominal output power. Both units are located in the aircraft nose compartment. Access to the units is through the upper right access door. Internal cooling fans pull air through the TRUs. The TRUs supply DC power to the secondary buses when an AC generator or external AC power is available to the variable AC buses. During normal operations, each TRU receives AC power from its related AC generator through its related variable AC bus. 2 TRUs receiving 3-phase 115 volts variable AC power can power the complete DC system. The electrical power control unit logic closes the secondary to main bus ties to accomplish the powering. A left or right TRU caution light illuminates if the TRU is offline or has failed. A left TRU hot or right TRU hot caution light illuminates when the related temperature sensor detects an over temperature condition in the TRU. Once the temperature decreases below the triggering limit, the related caution light extinguishes. When in flight, the airplane has 4 separate sources of DC electrical power supply generation. The sources are 2 engine-driven DC starter generators and 2 TRUs, each powering its dedicated DC bus. In normal operations, each power source powers its dedicated bus. The TRUs power secondary buses and the DC generators power the main buses. The Electrical Power Generation and Distribution Systems, or EPGDS, is monitored and protected from failure interruptions by the Electrical Power Control Unit. The Electrical Power Control Unit, through control of 4 bus tie contractors, ties affected buses together for power continuation when a DC generation source fails. During situations where 2 DC power sources are not operating, the Electrical Power Control Unit ensures that all DC buses are powered. If there is a failure of more than 2 DC power sources, automatic load shedding occurs. DC load shedding with failures of more than 2 power sources may result in the loss of power supply to the main buses. The 4 contactors that are controlled by the Electrical Power Control Unit and keep the buses powered in the event of a failed power source are 1. The left main bus to the right main bus. 2. The left secondary bus to the right secondary bus. 3. The left main bus to the left secondary bus. And 4. The right main bus to the right secondary bus. In the event of an engine-driven starter generator's failure, the main-to-main bus tie automatically closes. This closing is done by the GCU and the Electrical Power Control Unit. The operating starter generator then powers both the left and the right main DC buses. This happens regardless of the position of the bus tie switch on the DC control panel. Should one of the TRUs fail, the electrical power control unit closes the left to right secondary bus tie. The remaining operational TRU then powers both secondary buses. A failure of both engine-driven starter generators results in the electrical power control unit closing the secondary to main bus ties for both the left and right buses. The two bus tie connectors are often referred to as the vertical bus ties. The loss of both DC generators results in the closure of the bus ties and the TRUs powering all the DC buses. A failure of both TRUs results in the vertical bus ties closing. The power flow in this case is from the main buses to the related secondary buses, and the DC generators power all the DC buses. A dual TRU and a single DC generator failure results in the loss of 3 of the 4 DC power sources. In this case, the electrical power control unit automatically accomplishes some load shedding to reduce the load on the sole DC generator. The electrical power control unit closes the main bus tie so that both the left and right main buses remain powered. The electrical power control unit will not allow the main to secondary or vertical bus ties to close. This results in the loss of both secondary buses and any services that are powered by the buses. The scenario referred to as the emergency mode of operation for the airplane's electrical system, or the electrical power control unit's emergency mode, occurs when 1. The airplane is airborne, 2. The DC generators are not powering the system, and 3. At least one TRU is not available for powering. The electrical power control unit automatically disconnects the batteries from the main buses when in the emergency mode of operation. The main buses therefore become isolated. The essential and secondary buses remain powered from the batteries and the remaining TRU respectively. This results in the DC load shedding and the loss of the services provided by both main buses. During the emergency mode, the main and auxiliary batteries are automatically reconnected to the main buses should you attempt an airborne engine start. The connection of the batteries to the buses occurs even if the respective individual main battery, auxiliary battery, and standby battery switches are in the off positions. Remember, the main and auxiliary batteries are used to assist in engine starts and have a two-way flow to and from their main buses. The standby battery has only a one-way flow for recharging. The battery's connection to the main buses is only for the duration of the start attempt. Bus fault protection is provided for the main and secondary buses. The GCUs for the DC generators and the electrical power control unit operate in conjunction with each other to ensure protection. Whenever the electrical power control unit detects the potential of a DC main bus fault, it inhibits the closing of the main bus tie and also the main to secondary or vertical bus ties. The prevention of bus tie closures isolates the affected main bus. Upon the initial detection of the potential bus fault, the DC bus caution light illuminates. If the DC bus caution light illumination was the result of a spurious electrical malfunction, such as a transient voltage increase, the DC bus caution light and the master caution light will be the only lights illuminated. The non-normal procedure directs use of the bus fault reset switch located on the DC control panel. Momentary activation of the two-position switch to the bus fault reset position reinitializes the bus fault protection logic in the electrical power control unit. A good policy with any fault is to verify bus voltages on the electrical page on the multifunction display. Select the reset position to reset the electrical power control unit logic. The bus fault reset switch has reset the electrical power control unit logic and cleared the DC bus caution light. If after resetting the bus fault reset switch, the electrical power control unit confirms an actual main bus fault within approximately 5 seconds, the affected bus is automatically isolated. The electrical power control unit isolates the affected bus by 1. Disconnecting the DC starter generator, 2. The related battery or batteries depending on which main bus, left or right, and 3. Inhibits closing of the main bus tie and the main to secondary bus ties. A left main bus fault is indicated by illumination of the DC bus, the number 1 DC generator, the standby battery, and the auxiliary battery caution lights. A right main bus fault results in the illumination of 3 caution lights: the DC bus, the number 2 DC generator, and the main battery. A secondary bus fault results in the isolation of the affected secondary bus. A secondary bus fault occurs when there is an excessive electrical load associated with the fault. The excessive load causes the TRU circuit breaker, on the 115 volt AC variable frequency circuit breaker panel to trip. With the TRU circuit breaker tripped, within seconds the electrical power control unit detects the failed TRU and closes the secondary to secondary bus tie. The closed tie allows the opposite secondary bus to send power to the faulty bus. The excessive power draw causes a 150 amp cross tie fuse in the secondary to secondary circuit to blow. The faulty secondary bus is isolated and all services from the bus are lost. The TRU caution light for the affected side remains illuminated. The AC portion of the EPGDS receives power from two AC variable frequency generators in normal operation. For AC electrical systems ground maintenance, an AC external receptacle is located on the inboard side of the right engine nacelle. An AC GPU is used for power. AC external power is controlled by the left switch on the AC control panel. The panel is located at the top right side of the overhead panel. The switch is a two-position switch with off and external power. Applying AC external power to the aircraft connects the power supply to the left and right variable AC buses. The AC external power supplies power to all the AC and DC buses. The electrical power control unit closes the secondary to main bus ties to make this happen. AC external power on is displayed in green letters at the top right corner of the electrical page when the AC external power switch is selected on. The TRU loads and voltages for all DC buses are displayed on the multifunction display electrical page. During engine starts, the secondary to main bus ties are opened. The TRUs have a 300 amp limit and could be damaged. AC external power is not used for engine starts. The AC external power voltage and frequency is monitored by the External Power Protection Unit or AC Power Protection Unit. The AC Power Protection Unit checks power for acceptable limits, or it rejects the connection to the aircraft. The voltage levels are under voltage 106 volts AC plus or minus 2% and over voltage 124 volts AC plus or minus 2%. The AC Power Protection Unit checks the power supply frequency for trip limits. The limits are under frequency trip point of 370 Hz plus or minus 2%, over frequency trip point of 450 Hz plus or minus 2%. The AC Power Protection Unit also checks for equality of phase rotation for ABC phases. Normally the phases are separated by 120 degrees. The AC Power Protection Unit is installed on the right AC contactor box. The AC contactor box is in the right main landing gear well. There is an AC contactor box in each gear well for the respective side AC electrical system. The two 115 volt AC generators supply three-phase variable frequency with a normal range of 340 to 560 Hz power to the AC variable buses. The generators are mounted on the upper left aft side of the propeller reduction gearbox or RGB. The AC generators are oil-cooled, receiving pressurized oil from the gearbox to cool and lubricate the internal components. This oil is then scavenged and returned to the gearbox. AC electrical power is provided by the AC generators when the engines are operating and the condition levers are at or forward of the selection settings for minimum propeller RPM of 850. The AC generators are controlled by the Generator 1 and Generator 2 switches. The switches are located on the AC control panel at the upper right side of the overhead console. The Generator 1 and Generator 2 switches are maintained in the on position unless an AC malfunction occurs. Click on the switches to see more on providing power to the AC generators. When the engines are operating, moving the condition levers forward of the minimum propeller RPM of 850 position provides AC generator power supply to the dedicated left and right variable AC buses. The electrical page on the multifunction display displays the voltage and load for each of the generator's three phases. The displays are labeled AC Generator 1 and AC Generator 2. The phases are listed from the top down as A, B, and C. The volts displayed on the left side for each phase are shown digitally in white. The loads shown on the right side are digitally displayed in white as a percentage of maximum capacity. A plus sign to the left of the load figure indicates an overload of the AC power source. The systems and components requiring the 115 volt variable AC power are 1. The de-icing and anti-icing heaters, 2. The standby hydraulic pump, a backup for the number 1 hydraulic system, 3. 2 transformer rectifier units, and 4. The number 1 and 2 auxiliary fuel pumps. The 115-volt AC variable frequency circuit breaker panel presents a depiction of the AC-powered items. The AC panel has a circuit breaker for each phase, and the circuit breaker panel is located behind the co-pilot's seat. The AC generators are controlled and monitored by their respective GCUs. The GCU automatically takes its AC generator offline in response to certain AC electrical malfunctions. The faults can be a generator failure, an AC bus fault, or a generator overheat. A failure of either AC generator causes the related number 1 or number 2 AC generator caution light to illuminate. The crosstie of the operating generator closes, automatically enabling it to power both the left and right variable AC buses. The loss of an AC generator causes the shedding of the 115-volt AC galley power. The AC crossties are in the AC contactor boxes. The crosstie connects the AC external power supply, when in use, to the AC variable buses. An AC generator's GCU protects it from excessive loads that may result from an AC bus fault. If the GCU detects a bus fault, it automatically isolates the bus. All services from the affected bus are lost and the related left or right AC bus caution light illuminates. The generator that was powering the faulted bus continues online, isolated from the faulty bus. The scenario provides a backup in case the other AC generator fails. An overheated AC generator is indicated by illumination of the number 1 or number 2 AC generator hot caution light. The crew action is to turn off the applicable generator switch as called for in the abnormal procedures. This action provides load reduction, allowing the generator to cool. One AC generator with both TRUs and AC buses operational is capable of providing power for the aircraft's complete AC and DC electrical system. The EPGDS uses circuit breakers and current limiters for system protection. These two forms of protection are classified as passive protectors. Circuit breakers protect the power sources, bus distribution system, and component control circuits. The circuit breakers are located in or on panels or contactor boxes. The various locations for the circuit breakers are in the flight deck, in the nose compartment, in the left and right main landing gear wheel wells, in the wardrobe, and in the galleys. 4 circuit breaker panels are in the flight deck. The left and right 28-volt DC circuit breaker panels are located outboard and slightly aft of the pilot and co-pilot seats respectively. The avionics and the 115-volt AC variable frequency circuit breaker panels are located respectively on the left and right sides of the flight deck aft bulkhead. These panels are above the 28-volt DC circuit breaker panels. 2 contactor boxes are located in the aircraft nose compartment upper section. The first is the DC contactor box. It provides the control and distribution of DC power sources, those being the DC generators, TRUs, the main and auxiliary batteries, and DC external power. The second contactor box in the nose compartment is a smaller box mounted forward of the DC contactor box. This box is the standby contactor box. On some aircraft, this box may be located in the aft fuselage compartment. The standby contactor box is used to energize the number 3 hydraulic system DC motor pump. The circuit breaker for the pump is on the box. Each main landing gear wheel well has an AC contactor box installed on the left side in the well. The contactor box components provide the control and distribution for the AC power sources. This is where the circuit breakers for the AC variable bus frequency and the propeller anti-ice are located. The cross ties for the automatic switching in the case of an AC generator failure are in the AC contactor boxes. The wardrobe at the forward area of the cabin has additional circuit breakers. The breakers in the wardrobe are for maintenance and avionics. The circuit breaker panels at the galleys are for galley equipment heaters and area lighting. Each circuit breaker is referenced and identified by the panel it's located on, the electrical bus it serves, an identification label on the circuit breaker panel where the breaker is located, and an alphanumeric cross grid for locating the breaker. Look at the left DC volt circuit breaker panel. See that it is divided for 3 buses, left main, left essential, and left secondary. Along the left side of the panel is a row of numbers with the number 1 at the bottom. Along the bottom of the panel are letters in alphabetical order starting with A at the left. The standby, auxiliary, and main battery have the same takeoff maximum load meter limitation of 0.1. The minimum battery temperature for takeoff is -20 degrees Celsius. This concludes the electrical module.